This is a tutorial on simplifying rational functions. Whenever we discuss rational functions, we always have to worry about excluded values. These are values in our domain that would make our function undefined. Or you can think of them as values of x that make our function not make any sense. Now remember, you can't divide any number by 0. 3 divided by 0 would not make any sense. So, when we have a rational function, there's usually variables in the denominator. So what we're worried about are values of our variables that will make our denominator equal to 0. And to find them, I take our denominator, in this case x minus 4, and I set it equal to 0. If I do that, I add 4 to both sides and I get x is equal to 4. Now if x is equal to 4 and I plug that in, I'll have 4 over 4 minus 4. 4 minus 4 is 0, so we have 4 divided by 0, and that doesn't make any sense. So my excluded value then is when x is equal to 4. Or I would say that x can be any number except for 4. So x cannot equal 4. Let's look at our next example here. We have 4x minus 8 over x squared plus 3x minus 10. Now again, we're looking for values of x that would make our denominator equal to 0. So if I take this x squared plus 3x minus 10 and I set it equal to 0, then I'll need to solve this for values of x that'll make it equal 0. Now this is a quadratic equation, so this can have 2, 1, or 0 values of x that would make this equal to 0. The easiest way to solve this one is to factor, and this factors into x plus 5 and x minus 2. Now x plus 5 times x minus 2 is still equal to 0, and I can use the zero product property. And that means that each one of these binomials, if one of them equals 0, then it doesn't matter what the other one equals because that's just multiplied by 0. So I can take each one separately and set it equal to 0. Now if I have x plus 5 is equal to 0, I can just subtract 5 from both sides and I get x is equal to negative 5. If I have x minus 2 is equal to 0, then I would add 2 to both sides and I get x is equal to 2. So these are my excluded values. If x is equal to negative 5 or x is equal to 2, then my denominator here will equal 0. And then this function would not make any sense. So again, that means that we can have all values of x that are real, and we can plug them in and get an answer, except if x is equal to negative 5 or x is equal to 2. So we would say that x cannot equal negative 5 and x cannot equal 2. So now that we know how to find our excluded values, let's talk about simplifying rational expressions. When we simplify a rational expression, the first step is to always find your excluded values. So here if I have 9x squared divided by 12x, so if I wanted to find my excluded values, I would look at my denominator and I would set it equal to 0. So 12x is equal to 0. If I divide both sides by 12, I get x is equal to 0. So my excluded value then is x cannot equal 0. Now to simplify this rational expression, I'm going to break my numerator, this 9x squared, into 3 times 3 times x times x. Then I'm going to take my denominator and I'm going to break it into 3 times 4 times x. Now, whenever you divide a number by itself, say 2 divided by 2, that's equal to 1. And that works for variables too. If I have x over x, that's equal to 1. So that means that if I have 3 divided by 3, these 3's will cancel, because this would be equal to 1 And then I would just be multiplying this 3xx and 4x by 1. Also, these x's are going to cancel. So my final solution then would be 3 times x over 4, or 3/4 x. So this is my simplified rational expression. Now notice that our simplified expression here, 3/4 x, doesn't have any variables in the denominator. The domain of this function would be all real numbers. But this function came from our original rational expression, or rational function. And the domain of this guy was all real numbers except x could not equal 0. So because our answer came from this rational expression, that means the domain comes along with it. So our simplified rational expression then is 3/4 x, but we also have to note that x cannot equal 0. Let's try this again. Here we have 27x squared divided by 15x to the 4th. Now 27 I'm going to break down into 3 times 3 times 3. And x squared is just x times x. This is divided by 15x to the 4th, or 3 times 5 times x times x times x and times x. Now these 3's will cancel, these x's will cancel, and these x's will cancel. And we're just left with 3 times 3, which is 9, and then 5 times x, or 5x squared. So this is my simplified rational expression. But I have to go back to my original and look for excluded values. So I look at my domain. I have 15x to the 4th, and that's set equal to 0. Divide both sides by 15, and you'll get x to the 4th is equal to 0. Take the 4th root. The 4th root of 0 is 0, so x is equal to 0. But that's my excluded value, so x cannot equal 0. So my simplified rational expression then is 9 over 5x squared, but I also have to note that x cannot equal 0. Now sometimes when we simplify a rational expression or a rational function, we don't just eliminate numbers or variables by canceling. Sometimes we can cancel out a whole binomial. So let's look at this first example. We have 4x minus 8 over x squared plus 3x minus 10. Now my first step is to find my excluded values. So I'm going to take x squared plus 3x minus 10, and I'm going to set that equal to 0. Now the easiest way to solve this quadratic is to factor it. And this is going to factor into x plus 5 and x minus 2. Therefore, by the zero product property, I have x is equal to negative 5 and x is equal to positive 2. But these are my excluded values. So that actually means that x cannot equal negative 5 and x cannot equal positive 2, because if they do, then my denominator is going to be 0. Now to simplify this, I'm going to leave my denominator in the factored form. So my denominator is still going to look like x plus 5 times x minus 2. Now my numerator, this 4x minus 8, I'm going to take out a greatest common factor of 4. If I do that, this is going to turn into 4 times x minus 2. And if I write that in here as my numerator, 4 times x minus 2, notice that I have an x minus 2 in both the numerator and the denominator, which means I can cancel this binomial. So my final solution would be 4 over x plus 5. But my domain for my original function goes along even though we simplified this function. This 4 over x plus 5, its domain would be all real numbers except when x is equal to negative 5. But because our original function also couldn't have x equal 2, that means our simplified expression also can't have x equal 2. So our answer would be 4 over x plus 5, and then we would have to note that x cannot equal negative 5 and x cannot equal 2. Let's try this again. Here we have x squared minus 2x minus 3 over x squared plus 6x plus 5. Now the first thing I'm going to do is look for excluded values. So I'm going to take this x squared plus 6x plus 5 and set it equal to 0. Again, I can factor this quadratic into x plus 5 and x plus 1. This is equal to 0, and through the zero product property, I can see that x is equal to negative 5 and x is equal to negative 1. Now because these are excluded values, that means x cannot equal negative 5 and x cannot equal negative 1. X can equal any other number except for these two, because these two make our denominator equal to 0. Now again, I'm going to leave my denominator in its factored form. So I'll have x plus 5 times x plus 1 in the denominator. And I'm going to have to factor my numerator. This will factor into x minus 3 and x plus 1. So if I write that in as my numerator, I have x plus 1 times x minus 3. Now notice that I have an x plus 1 in both the numerator and the denominator, so I will cancel them. And my solution then is x minus 3 over x plus 5. But I also have to note that my denominator in my original function has restricted my domain to where x cannot equal negative 5 and x cannot equal negative 1. Now the last thing we have to talk about is just a special trick when you're trying to factor out or eliminate a binomial. So let's try to simplify this rational function. Our first step is to find our excluded values. So we take x squared minus x minus 6, or we take our denominator, and we set it equal to 0. Now I can factor this into x minus 3 and x plus 2. If that's equal to 0, that means x cannot equal positive 3 and x cannot equal negative 2. So these are my excluded values. And I'm going to leave my denominator in its factored form. I have x minus 3 times x plus 2. Now my numerator, this 12 minus 4x, I can factor out a greatest common factor of 4. If I do that, I'll have 4 times 3 minus x. Now notice that this 3 minus x looks awfully similar to this x minus 3. So what I'm going to do is I'm also going to factor out a negative 1 from this binomial. If I do that, this becomes 4 times negative 1, and that's times negative 3 plus x. And then if I rewrite this, I can rewrite this as x minus 3, because that would mean the same thing. So my numerator then is just a negative 4 times x minus 3. Now I have an x minus 3 in both the numerator and the denominator, so they cancel and I'm left with negative 4 over x plus 2. Now the trick was just factoring out this negative 1, because by doing that, I was able to rearrange the terms of my binomial so they were the same as the binomial in the denominator, and therefore I could cancel them. So my solution then is negative 4 over x plus 2, and we have to note that x cannot equal 3, and x cannot equal negative 2. And that completes the tutorial on simplifying rational functions.